So, hello guys, this is Satyam Tiwari, and today we are going to solve this question which is called maximum subarray problem. Okay, so here we'll try to understand an algorithm called Kadane's algorithm. Okay, so the question is given like this: we have given this array and we need to find the sub array so that the sum of that sub array will be maximum. Now, I'm talking about sub array means it should be continuous. Either it can be -2 -2 1 -3 or any possible combination of these elements, but it should be continuous. That is called subarray. Okay, so the thing which you can do is, if you are not thinking about time complexity, is just find all the subarray of this array. Suppose our problem statement is like this: for like the sample solution, sorry, the sample input is this. Okay, so what are the possible subarray which we can make from this is 4 3 2, then 4 3, then 3 2, then 4 3 2. So out of this you can find the maximum sum, which is 432, and you can print output as 4 9. Okay, so this is how the you can approach the solution if the time complexity is not given. But here it is clearly given that we have to find the solution in order of n time complexity. That means only in one go we have to find out which is the maximum sum of the subarray, or which is the subarray which has the maximum sum. Okay, so what can we do so that we'll get order of n solution? Now, if you don't know what is order of n, it's actually you have to do it in one for loop. See, if you are finding the subarray like 432 and you are finding the subarray, how you will do is you will create two for loop. One will be the parent for loop which will run from 4, then another for loop. Okay, then only you will be able to find out the subarrays, and this will take the time complexity of order of n square. N is the number of input, but here see n square. Why? Because we are we are running it twice, like n square. For 4 again we are running 3 2, for 3 again we are starting from 432, for 2 again we are starting from 432. So that's why order of n square. So we have to solve it only in one for loop, that is order of n. Okay, so let's see how we can do. So what we can try to do is we can try to have two variables. We'll use Kadane's algorithm. You can just I'll give you the link of some of the problems of Kadane's algorithm. So what is Kadane's algorithm is, so we can take two variables here. One is the current sum, which denotes the current sum till now. Okay, the current sum till now, and the second variable will be denoting the maximum sum till now. So first initialize this with 0, both the variables. Now we'll see this Kadane's algorithm using this input. Okay, so run a for loop. For loop will, inside the for loop, give the condition that it should run from first element to the last element, the usual for loop. Okay, and the first thing you have to do is, and like you have to initialize these two here outside the for loop. The first thing you can do is you have to see current sum is to find out the sum up to that pointer. Okay, if the for loop, like the pointer is here, you have to find out the sum between these two. If the pointer is here, you have to find out the sum up to now, up to -3. If the pointer is here, you have to find out the sum up to -1. So that thing will be denoted by current sum up to now. And the maximum sum will be, if suppose our pointer is -1, so up to -1, which sub array has the maximum sum will be stored in maximum sum until now. Okay, so I hope you are getting it. We'll see the example and you will be understanding very clearly. So let's see. So first, keep on adding. So what I told you, it will take all the sum which is present inside this array. So keep on adding current sum plus This is the same current sum. It's like sum is equal to sum plus a of I, array of I. Okay. So now at the first iteration, current sum will have -2. We initialized maximum sums sub array is equal to 0. Now we can see if this path maximum sum sub array, sorry, so if maximum sum sub array, if it is less than current sum, then only update the maximum sum. Okay, so what we are doing here is we are actually using the current sum to do all the operations, and we are using the maximum sum to just store the maximum sum of the subarray. Okay, so this is how we are going to solve it. Now the questions which will be popping in your mind is what we'll do with the negative terms, because here the negative term will reduce our value. So what we should do, we can do one thing. If current sum value, like if we are keep on ending and it is becoming less than 0, suppose -2 plus 1 minus 3, which is -4, right? So current sum has -4. So if -4 is less than 0, then this part of subarray is negative. Okay, so if you start from here 4, and if you add the previous sum of subarray, it will be definitely less than less than this value, right? This value will be reduced. So if this whole subarray the sum is negative, it's no need to add this subarray sum to this after subarray sum. Okay, if it is positive, then you can add. So if current sum is less than 0, you have to make current sum is equal to 0, right? Again you have to start computing from here, make it current sum 0, because now no need to find out what will be the maximum sum subarray, because you have already stored it in some variable called maximum sum up to now for the subarray up to here. Okay, so now let's see the code. Then you'll get it more easily. Okay, so first what I told you, we have to initialize current sum up to now is equal to 0, then int best sum is equal to 0. Okay, then use the for loop less than. Okay, now here comes the part. Current sum will take all the sum. Okay, so sums of I, then you need to compare ki if best sum up to that part of array, if you found out the maximum sum which is less than the current sum, that means update the best sum. Current. One more if condition you have to add. If current sum is less than 0, then there is no need of further calculation of that subarray. You have to leave that subarray. Okay, so you have to initialize the current sum is equal to 0. So what I want you to do is just try this thing with different input, and definitely you are going to get this problem. Okay, so now you can do is return. This is actually the solution of this problem, and this is called Kadane's algorithm. So just run it with your sample input and try to understand with different subcases, and you will easily get it. Okay, if you have any doubt, you can just mail me or just comment down this video. Okay, thank you.